Or we can't hear you.
Yeah, I'm not speaking. I'm just waiting for another 3 minutes. 7:32. Pass
Yeah,
through,
we
then
are-
I will start.
We will start like sharp at 7:30.
Yeah, that's what.
Yeah.
Another
So,
3 minutes are there.
yeah, yes. Thank you, sir. Thank you.
Shine, shall we start?
Yes, sir. Yes.
Okay, dear members, we are restarting our webinar program after a break. Last webinar was in January this year, and webinar committee is now planning to conduct at least one webinar in each month. So today's session is on floating solar plant project execution, operation and maintenance by engineer Anand Malak, additional general manager Random RE Solar, NTPC Kayangulam. A mechanical engineer by profession, he started his career in thermal power plants and later switched over to renewable energy sector and has over 25 years of experience. He was instrumental in the erection of a 90 megawatt floating solar power plant at Kayangulam. A brief video of the solar power plant is already shared in our groups. Engineer Anand suggested for an interactive session, so I request all of you to actively participate in the session. On behalf of KCB Engineer Association, I wholeheartedly welcome Engineer Anand Malak to this webinar program and request Anand sir to lead the session. Over to Anand sir.
Jai Shankar sir. It's a privilege to be part of this webinar series. I think I'm audible, sir.
Yes, audible.
As Jai Shankar sir has introduced, so I expect it would be better that both of us will benefit with as much questions as you ask, because the point is, what are the doubts in your mind? They are to be clarified rather than what I know and what I deliver. Maybe what I deliver may be useful or may not be useful. So I expect what I'll do is maybe around 15-20 minutes, a very small presentation to give an overview of that floating solar project. And if you have any doubt with respect to the solar power generation and floating solar in particular, you can always ask. And as an introduction, I can tell you that in India, so we are having very few floating solar projects, and this 92 megawatt floating solar project in Kerala is the second largest floating solar project as on date in India. The first one is at Ramagunda. So for a brief period of 7 days, that is in the month of June 2022, this particular solar project was the largest solar project in India. Now I will just go through my presentation. I will again play the video of 5 minutes. So in total, maybe around 20 to 25 minutes, the whole presentation will be completed. You can note down your questions, and at the end, we are open for this discussion. And I will keep as much time as possible or maximum time for this interactive session. To start with, this is the solar power generation. The sunlight from the sun falls on the solar PV modules, and that solar PV modules generates a DC current. So we have a positive and negative coming out from each module, and these modules are connected in a series parallel connection. So they are connected in series to increase the voltage, and then they are connected in parallel to increase the current. And after the series parallel connection, so the inputs will come to the inverter, which will convert the DC power to AC power, and that AC power is fed to this transformer, and this transformer will step up the voltage from 660 or 650 around that voltage to 33 kV, and from 33 kV we are going to feed to a common that indoor switchyard, and from there we have an air insulated substation of 33 by 220 kV substation, and finally the metering happens at the HV side, and the sole customer of this project is KSCB. This is a brief of solar power generation. So I start my presentation. Okay. I'll just go back for a few slides. So welcome to the floating solar plant at NTPC Kayamkul. A brief background is way back in the year 2016-17, around that year, you can see the central that floating solar plant, a very small floating solar plant. This is India's first that floating solar plant. It was a 5 kilowatt plant to compare the effect of the that floating solar vis-a-vis the land-based solar. Means what is the benefit of the temperature effect, that lower temperature effect. So that was the first source, that floating solar, and presently we have around you can say around this 225 that megawatt of that floating solar plants are already installed in India. And this presentation will just go through the brief challenges of construction as well as operation. And basically it gives an overview of what is the requirement. And as a perspective, to set the perspective right, I want to just tell that this was my first floating solar power plant, and I absolutely had no prior experience of what is going to come. It is there is a good old saying which says, "Let us cross the bridge when it comes." So we took up the challenges one by one as and when it came. Okay, so I say that the project may not be 100% perfect, but it is complete. So at the end of the day, what matters is not perfection. We have to deliver the goods. There are lacunae, there are deficiencies, there are problems, so which we have to tackle one by one over the days. And some of the problems were not even thought of, were not even envisaged with the magnanimity of the problems. They are really big problems. But anyway, the plant is in operation and it is running smoothly. So we have set up a 92 megawatt floating solar plant, the breakup is this 20 megawatt to the north of the existing plant, that is NTPC naphtha base, that is that liquid fired combined cycle power plant. So it is the combined cycle is we are having 2 gas turbines and 1 steam turbine. The total capacity is around 360 megawatts. And presently it is under preservation because the tariff is on the higher side. And in this case also it is KSEB who is the sole customer of this power plant. And so this 92 megawatt is split into 3 sections. That is this 20 megawatts to the north of the existing plant, 22 megawatt to the south, and 50 megawatt to the far south. So basically this water body is part of the backwaters. So you are able to see in this, there is that Arabian Sea, and way down where I have written the backwaters, below that there is an opening to the sea, wherein all the ships can go into the sea and they can do the fishing and they come back in this. Basically, this is National Waterway number 3, that is Kollam Kottapuram Waterway. It even goes beyond Cochin. And this is prior to the execution of the plant way back in, you can say, 2020 and 21. And this is the present satellite view of the 92 megawatt, that floating solar. So you can see that how it has been arranged. And the entire 92 megawatt was dedicated to the nation by our Honorable Prime Minister, Shri Narendra Modi ji, via remotely on 30th of July 2022. And just a brief of what is the specifications of our plant. So this is it was given to these 2 agencies, that is this BHEL, this 22 megawatt, and Tata Power Solar Systems 70 megawatt. So we had given around 170 acres and 310 acres, but it was also an experiment for us. So it was on the higher side. So it was that reduced, or you can say around 100 megawatt for 22 megawatt and around 280 or 250 plus around 350 acres for 70 megawatt. You can say around roughly that approximately 5 acres per megawatt. That's what you can have. And in 22 megawatt, we are having 330 and 335 watt peak modules, which are of Vikram Solar. And in 70 megawatt, we have 490 and 490 watt peak. They are the bifacial solar PV modules. And they are that half cut cells are there in that. And the number of modules in 22 megawatt is around 94,680 numbers. It comes to around 31.5 that megawatt. That's the DC input. And in the 70 megawatt is more than 2,05,000 numbers. It comes to around 101 or 101.5 that megawatt. The inverters, we are having 2.625 megawatt for this 22 megawatt. Actually, they are rated for 2.5 megawatt. There are 9 numbers, and for 70 megawatt, we have 5 megawatt, 14 numbers. The inverter ratings are 5.3 MVA and 2.7 MVA. And in 70 megawatt, we are having a 5 MVA that inverter. And the specialty of this 70 megawatt 5 MVA rating is it is based on ester oil. So in fact, if there is a leakage or anything which happens, so it gets, it will not have any adverse effect on the environment. The inverter transformer ratings are 630 by 33 kV. And in case of 70 megawatt, it is 660 by 33 kV. 660 volts by 33 kV. So the number of transformers are 4 and 1 in 22 and around 14 these transformers in 70 megawatt of 14 into 5 megawatt each. And all this power generated by this 92 megawatt is fed to two power transformers of 63 MVA, that is 33 kV by 220 kV, and hence the power. And finally, the entire power, the presentation has got cut at the bottom, that 100% capacity allocation is to KSEB. So KSEB is the sole beneficiary of this power generated. So this is the screen which I have already explained. And these are the actual photographs of the plant at Kaim. So the another point what is to be noted is in terms of this 22 megawatt, the inverters and the inverter transformers and the HT switchgears are on the land. But you can see the water behind it, which is very close. And this land is not firm. So we had to do the ground improvement for this 22 megawatt. Whereas in case of the 70 megawatt, we don't have any access to the land. Entirely the inverters, inverter transformers and HT panel and SCADA panel are in the water. They are on the floating platform. So this is the photographs of the anchoring. So it is very much known that these are that floating pontoons on which we are having a small equipments by which we do this anchoring. And these are the launching pads for this 22 megawatt. So there were two launching platforms, and after the assembly, it was stored to the location. And you can just note down in this, all the assemblies has to be done on the ground. It has to be only taken to the location and fixed to the anchors, which were done in the previous slide. And this is the cabling, which is this DC cabling from the modules to the SCB. SCB is that string combiner box, wherein all the strings are connected in parallel. This is the another view. And all the DC cables from that string combiner box, one positive and one negative, is coming from the field to the inverter. And this is a CMCS building which was constructed for the 92 megawatt, that floating solar plant. And we have a small auxiliary, this transformer for the auxiliary power requirement of that HT panel. And this is the two power transformers. We are having the firefighting system, that is the HVWS, high velocity water spray system. From here, the power goes through underground cables to our gas insulated substation. And just for information purpose, the gas insulated substation at NTPC Kayamkulam is the first gas insulated substation to be installed in India. So you can say we are having one of the oldest gas insulated substation, which was installed way back in 98-99. So that is also completed almost around 25 years of its life. Now this is the gantry towers which we made at that location. You can see this is for the evacuation of 50 megawatt. And we had to do this dredging at wherever the water level was that low. One important factor what I want to tell is this whole backwater is subjected to the tidal variations. So we are having these daily variations of the water level which moves up and down. We have that high tides and low tides. Ultimately, this is the photograph of the inverter, that floating platforms. So in this you can see it is that inverter. The same thing will be coming elsewhere also. ultimately what I want to sum and substance is we require land from which we have to load all these onto the floating platforms. And from there on, it will be pulled or stored to its respective location and where it will be anchored. It will be connected to the anchor. So it will move. There will be a movement because of this high tide and that low tide. And whenever it is that low tide, it gets extra that rope length. To that extent, there will be excursions. So the movement of these that floating bodies or the floating arrays or the floating platforms is called as excursions. And this is the actual photograph of this 20 megawatt. This is at the time of installation. So we made an attempt that can we install the modules inside the water. So it is not possible. So whatever has to be done, all the assembly installation has to happen at the ground only. And this is one such beautiful picture, that is evening picture. So wherein we had installed around, this is, you can see in the background that there are special structures so that the unevenness of this bund was done away with the plywood which were installed so that it could be that smoothly launched. And if you see in this, there is a white line at the right side. This is the HT cable, that line, and this is the road. So for me, the working area is only a small thing. And all the floaters were actually stacked just behind this, and all the modules were stacked elsewhere. And if you want to work for the next day, the required number of modules are to be shifted only one day before. So this just in time was ensured, and it was a perfect project monitoring or a perfect project planning and execution. And this is the moving of arrays. And we come to some operational issues, which is, this is just a background of how it was executed and what were the issues faced. And after installation and commissioning, so we face some problems like unauthorized entry of fishermen, safety and security is a matter of concern, pilferage of cables and other accessories, water hyacinth, and that obstructs the movement of the boats. Some engineering issues were there, and this bird droppings on the panel, which requires the regular cleaning of the panels, and this rodents damaging the 6 square mm DC cables, which leads to the problem of the inverter tripping on round fault, and the 50 megawatt area is exposed to large that wave that movements. And one more proposal is about the boundary wall. So how it is going to be executed, this is another challenge which we are in the lookout. So this is the unauthorized entry. So it's very difficult. And we are having this HT panel, you can see in this, wherein these boat people are moving above it. So the outer sheath has got damaged. And these local people also put some the rubbish on the solar PV modules, which you are able to see. Then we are having that LA, which are basically having some copper, so 500 or 600 rupees per cable. So they are also being that removed for salvage value, but we are at that higher risk. And this is that hyacinth which comes in the rainy season. So approach to our platforms is very difficult. Basically, it will make this delay in the repair and approach basically. And this is the rats are biting the 6 square mm cables, which whenever they bite, what happens is these cables will fall inside the water. And when they fall inside the water, it will create a ground fault. And hence the inverter, this trips. And you can just, I will be able to show a videograph. You can just see how large it is, and it is really a task to identify which cable has gone inside the water. And these are the bird droppings, actual bird droppings, and which requires regular cleaning. And some engineering issues were also there, and presently also they are there. These are the LAs which are installed just in the walkway. So because it is installed on the walkway, we have to be over cautious not to fall on that LA. Otherwise, there can be injury or an incident, a reportable incident, or it can even lead to fatal, because these are the really very sharp lightning arresters. And we are having one walkway after every 4 modules. So accessibility of modules is also a challenge, but it's actually this trade-off. In the sense, if you put every alternate or every 2 as shown in the top photograph, if you place like this, then the amount of water body required will increase. Plus the cost also increases. And this platform was not there, which was subsequently made. And again, this is a local modifications so that people can easily access the inverters. And this is the inverter of 5 megawatt. You can see it is a very compact inverter. And this inverter is the first inverter to be imported with 5 megawatt. So you cannot, since it is a floating platform, you cannot have that huge structures or a canopy on this, because the moment you put canopy and other structures, the stability of the floating platform comes into picture, and it becomes more and more big, which is again cost prohibitive. Then one marine boundary wall we are planning to do so as to prevent access from all the sites what we are having presently. This is the pile and slab which is being followed in Alappuzha district by the irrigation department. We had visited it, we have noted, now we'll have to see how to implement this. And this I say thank you. And this is my presentation. And what I want to say is, since all of you may not have seen the videograph, so I will just play the video for another 5 minutes or so, and then we can have for this discussion. This was a 20 megawatt, this was for the 22 megawatt, and it was a 50 megawatt. So we give this marine safety, this training also. And this is the vegetation clearing by dredging, use of firefighters, dredging. These are the anchor plates. The anchor plates and ropes. They are placed inside. There's 2 anchors which have been placed. A very limited work area where we had, and all these modules were brought just in 1 day before. This is the working area, and you can see in this, even for placing a small, we have to hire a larger capacity. This is the assembly area for 50 megawatt. You can just see. Actually, stowing can happen only when there is no wind. If there is wind, then we have to park it like this separately. Assembly area. This is how we used to do the stowing. There used to be these 2 boats, one at the front and other at the back, and all the boats were hired from the local. You can see in this that the water moves very easily at the bottom. These are basically the sealantary floaters, but for the other floaters, they are a bit difficult, they are box type. The maximum you can say more than 1,000 modules were stored in a single that array. So the challenge what we faced, big ships were coming, and you can just see how it has taken a turn. And just for information that it was not a planned activity here. So it was all by luck that our drone was flying at that time and we encountered the inverter floating platform, with an inverter transformer and a HT panel. They have put the danger boards, but you can see the hyacinth also at the back side. This is for the 22 megawatt. All the inverters are on the land based. You can see in this the lightning array systems are of a different type. There is a small hole in between. 20 megawatt. Huge area. Work which we completed and aerial view. You can see the hyacinth also. Okay, I think I have completed the presentation and what I have to say. Now it is open for this discussion. Any questions you can ask.
Shine, there is one question in the chat box. How the earthing requirement are met from various equipment, lightning arrestor platform, etc.
Yes, sir. This earthing, what we have done is, we have made an earthing block which is going inside the bed. So the bed is just, actually this water depth here is around 1.5 to this 2 that meters. So we have made a concrete block, and that concrete block has some spikes at the bottom, copper spikes, and they are connected, and we are having a bus bar, and it is earthed through the water, inside the water. That is, it is earthed in the bed.
Sir, regarding this anchoring excursions, how much variations is permissible in this case? Water level variations.
Sir, it varies around 5 to 10 meters. You can say around, it is designed for around this 2 meters, but that anchoring is not accurately done at some locations. Plus a variation is around 1 meter, water variations are there. So around 3 to 4 meters excursions do happen, and we should have that extra cable length. If there is a cable length is extra, then there is not much of an issue in that. You can see in this, there are so many that loops. So all these extra loops will take care of the excursions only.
That means the floating panels in the set in a string will whether it will affect the neighboring string, etc. due to this movement. The movement of the one of the strings may there are chances for affecting the neighboring string, the gap between the strings, etc.
Sir, actually what generally happens is, if at all, it will only move with respect to the wind, and the wind will generally affect all of them that uniformly. Even in the worst case also, that even if one moves in that X direction and the other moves in Y direction, those things are taken care of by that extra cable length.
Okay, thank you, sir. One question in the chat box: whether synchronization is done for each inverter?
Synchronization is done at the inverter that automatically. We don't that switch on and switch off the power supply. So at the end of the day, it gets disconnected. And in the morning, when there is sufficient sunlight, maybe even at around 10 watts per meter square, our that inverters get synchronized. Generally between 6 to 6:15, they get synchronized.
So, since Kerala is very much lightning prone, is there any issue occurred because of lightning there? Sir, one more question: how much efficiency you are getting from this plant?
Pardon, sir, the second question: how much efficiency?
How much efficiency you are getting? What is the value of efficiency you are getting from this plant?
CU of maybe.
Okay, fine. For this lightning, we have put this lightning arresters, and you have already seen that this cable which is supposed to do the earthing is already missing at some locations. So this is the challenge what we have faced. The local people are making this theft. We are replacing it to the extent possible, and it is our plant. We have to maintain it. So as of now, for the last, we have commissioned in last June, and we are in the beginning of June this year. So we have not faced any lightning issues as of now, or there is no damage due to lightning. And coming to your second question, that what is the capacity utilization factor? So the capacity utilization factor of this plant is approximately around 23 to 24 for the last year. So we intend to hit to 24 to 25. Maybe approximately around 25 should be our target, or that achievable one.
So when compared to the other solar, is it higher or is it lower?
Sir, I cannot say that whether it's higher or lower. Previously, we used to have 1:1 this DC capacity. That is, if I have put that 100 megawatt AC capacity, I used to put 100 megawatt DC. Now with the module prices coming down, we are going 10%, 20%, 30%. So up to 40, 45% people are going extra. At some places, they have gone even up to 50 to 60%. So that is how it is, sir. In the sense, when you put extra DC, you get extra here, because this dividing or this denominator is this.
Now, I will frame the
DC
question
capacity.
differently, because if you are putting a floating solar, is it more capacity can be utilized for the same area when you compare it to the land area?
But it's not like that.
Because no
To some
shades are
extent,
there.
yes, sir, I will tell you, sir.
Hmm.
Actually, there are two things in this. One is the angle of inclination. All our solar PV modules are inclined at 5 degrees. Across anywhere in the world, it will be 5 degrees only. It cannot be that more than that, or that less than that. The reason being, if it is that more, then the uplift forces will increase, which will be this difficult to manage. So hence they are almost like that flat. So when you go for increase in the angle of inclination, the area required will be slightly more in the land based, if it is inclined more, or if it is 5 degrees, then it will require the same area what is there on the that floating solar. It is basically the angle of inclination which will decide.
Okay, thank you. And is there any protection or extra requirement or regarding the protection or relay or something like that?
They are the same protections over current, and all these inverters actually this strip because of this ground faults. Suppose if this DC cable gets cut and goes into the water, and this water is basically I that missed out, which one of the person has asked, that it is the brackish water. The salinity of this water varies with respect to the season. So in the rainy season, it will be that less saline, and hence the hyacinth is able to survive. And in the winter season, it is that more saline or that more salty, and the hyacinth will automatically die in that period. Then what question was there?
Project cost for 22 megawatt and 70 megawatt.
The project cost was around for 22 megawatt, it was around 110 crores, and for 70 megawatt, it was around 360 or 370 crores. Total comes to around 470 crores. Around, you can say 500 crores the total project cost. Approximately 500 crores.
One question in chat box. Any harmonics issue for your plants?
No, sir. There are no harmonic issues because these are already tested, and they are that standard equipments which are available in the market, which have been purchased and installed.
Any corrosion issues due to seawater?
Definitely, yes, sir. That we have to tackle. That is an issue. Painting has to be done on the regular basis. So it's a challenge. In fact, that humidity is also very high, and water can seep into very easily. All our equipments are outdoor units. That's a challenge, yes.
One question in the chat box. This water-based earthing, will it cause issue during fault conditions? Is specifically asking regarding electric shock in water body.
We have not experienced, sir, but definitely yes. It is we should use our PPEs to avoid any that electric shocks. And yes, if there are no PPEs, definitely we do get shocks. And this DC shock is more dangerous. Huh? That is really a challenge.
What type of inverter is used? Is it string type? It's a question from the chat box.
Pardon, sir, what type?
What type of inverter is used?
But yeah, actually I have not gone into my presentation in a full way. So actually what happens is any solar plant, the heart of a solar plant is an inverter. So once you decide on the size of the inverter, then the array sizes, everything will be decided based on the inverter size. So for the inverters, based on our technical specifications in the tender documents, it was specified for 1500 volts DC. So based on which they had implemented this inverters of 1500 volts DC capacity or this voltage specifications, and all this array number of modules which are to be fixed in one array, that's series parallel combination, is also dependent on the inverter DC voltage. And to be more specific, we are used this actually the delta inverters, this 2.5 that megawatt, 9 numbers, and Sungrow inverters 5 megawatt, and both of them are of 1500 volts DC that rating.
Another question from the chat box. The cooling of panels, does it affect efficiency?
Yeah, it actually does increase the efficiency by say around 4 to 5 or 6%, 4 to 6%. Yes, it does.
Protections provided at DC side.
Only this protections, as I told, if there is an earth fault, it is basically that floating neutron. Okay. If there is this ground fault, I told you, even if that 6 square mm cable gets cut, so that will give you this ground fault. So that ground fault will strip the inverter. So the inverter will stop.
Next question is regarding the cleaning of the panels. How frequent
Yes.
you are cleaning and how is your procedure for it?
We have put that freshwater water tanks on the ground, and we have made a pumping system for that fresh water, and we have laid a pipeline at all the areas, and from which we are putting a for the last mile connectivity, you can say. So there we are using that flexible hose, and it is being cleaned manually with fresh water. We are not using the water which is just below the panels.
What is the frequency in which you are carrying out this activity?
Frequencies on one or two teams are doing it on a continuous basis, and our target is to clean it 2 times in a month. Target is 2 times in a month.
Okay, thank you, sir. Next question from the chat box. How many inverters do you have and capacity? That is already in your slides, I think. But if
9 and 14.
Okay. Then next question. What's the reactive power that can be generated when supplying maximum power output?
Presently, there is no that hiding of facts. Presently, we are operating at that unity power factor. And if at all you want the reactive power factor, it has commercial implications, which may be dealt separately.
What will be the probable cost of a unit power generated from this plant?
This presently the tariff, the ceiling what PPA had happened was ₹3.16. That was the upper ceiling. The tariff presently is defined as 2.94 by CRC. This is a tariff determined project.
Another question is that, as you said, the bird dropping is a big issue there in that particular project area. So obviously it requires very frequent cleaning as well. So in that way, the frequent cleaning will definitely affect the life of the panels. What's your expected life of the panels? That way you have installed this project.
The life of the panel is 25 years. It is irrespective of the bird that is dropping. Basically, what you told is correct, wherein whenever there is a bird droppings, so that is going to create hot spots. So that is not factored into the life of the project, because it is supposed to be without bird droppings or without any shadow. Any solar plant has to operate without any shadow. So, but there are some challenges. So the output of it may come down, or some modules may also fail because of these hotspots.
Sir, next question from chat box. How many feeders you take out?
Feeders we take out from which place?
I think it is question is regarding 33 kV feeders.
33 kV. Okay, fine. So we have this is basically a part of this design aspect, which is left to the bidders or the successful bidders. So in our present case, we are having a 15 megawatt feeders, which is our internal that switch yard mein. So we are having each feeder is 15 megawatt. So accordingly, it has been that looped. So in Tata, it has been looped such that first 5 will come to the next one, and there are isolators in that floating platform only, and that 5 plus 5 will become 10, and that 10 will go to the next platform. So that will become 15, and from that 15 will directly come to the control room. That is that HT switchgear. And in BHEL, it is 5 plus 5 plus 5. It comes at a single place and it becomes 15. So it is basically a 15 megawatt each feeder.
Whether the floating substation is manned or unmanned?
Manned, sir. We can have unmanned, but whenever there is equipment this stripping, they have to go and attend it. And the accessing the location is also a challenge. You cannot go the way you want, and the speed of the boat is also very slow. And you can just see here, if you can see in the photograph, if I have to come from this to this, are you able to see my cursor?
Yes, sir. Yes, sir. We can see.
Moving. Okay. So if I have to come from here to here, I have to go all round and come. My boat cannot pass like this because there are the HT panels and all other cables passing here.
Oh, okay. So another.
And you just see this whatever that rectangle which is there in front of me. This is for equivalent to this 2.5 that megawatt. This is around 3.6 megawatt DC. Okay. In this, any one cable gets cut and falls inside the water, the inverter is going to this strip.
Okay, sir. Then one question is regarding the performance of bifacial solar panels, whether it is higher than the normal panels.
Yes, definitely it's higher. That also adds to around 5%, 4 to 6% you can take. Yeah, yes. But proportionately, the cost is also high. In fact, what happens is that's actually this trade-off. So you want higher output and get the output in that smaller area.
So in that area which you have put the solar, have you seen any difference in environmental, maybe inside the water?
Inside the water, there are no environmental effects. On the contrary, the amount of fishes have increased below the panels because the people don't go there for fishing. Now people are risking their lives going below the panels for fishing.
Okay.
That is again a challenge which is very difficult to handle.
So because of non-incidence of solar rays, there is no issues like that.
Nothing.
Okay.
Because the whole water is subjected to the in and out because of this tides. So the fresh set of water comes in and it goes out.
Okay.
And point is, you can just see, we have used a very small portion of the water body. There are still a vast area which is that exposed to sunlight. Even in between the modules also, there is path for the sunlight to go inside the water.
Next question on the chat box: what's the temperature at which solar panels are working?
Around 50 degrees.
Then one question is regarding the type and make of panels. That I think you have already in the slides. It was there. Whether you can repeat
solar for this 22 megawatt and this Trina solar bifacial for 70 megawatt.
Another question is regarding What about the size of each type of 395 watt peak and 495 watt peak? Any efficiency difference between them or technology of manufacturing? Two type
That's
of
what I-
panels.
Basically, this is this 330 watt peak is your normal, the regular modules which are available in the market, and they are of that Vikram Solar, made in India. And for this one, it is for the bifacial. What they do is they have got for that half cut cells. So you can check. So there are what is called as half cut cells or one third cut cells. So this 490 watt peak, what they have done is effectively it is having a 75 plus 75. Total 150 cells are there in that. So it is effectively these two modules in one frame. So that's what I can say. So efficiency is more or less the same. It will be slightly better. Around 21, yeah, 22 is the efficiency of the cells. Higher the efficiency, the overall size of the module decreases, and that lower the efficiency, the size of the module increases. And in fact, presently it is very difficult to get that low efficiency cells. So we don't have modules of 250, 260 watt peak. By default, it is 280, 300 watt peak.
How will you transport the transformers into the floating plant?
Sir, that's what I showed in one of the slide, that all of them were kept at a particular location that is called as the launching platform. So a place where I can place my crane. Now, since I just want to answer it more directly, if one of the transformer fails, then how to replace it or repair it? So we have to disconnect all the cables, bring this platform to the shore, then bring a big this crane, simply that lift it with the crane, replace it with the new transformer, and take it back to its location, anchor it, and that do the reconnection.
Clear, sir. Clear. Okay. What is the maximum power output achieved so far?
Daily basis 100 megawatts.
What is the preventive maintenance schedule other than the cleaning of the panels?
Yes, sir. Basically, we go for the checking of that string currents and each that SCB. It's almost once in a month. All the string currents will be checked. Basically, we don't have any that string current monitoring system in our plant. So if at all one or two strings goes off, we don't come to know unless it goes into the water. If it goes into the water, then definitely it will strip my inverter. And HT panels, yes. And say around monthly or even once in a month is what is the PM schedule.
Next question is also in a similar nature. Any equipment used for the monitoring of solar penetration and generation?
We have what is called as a pyranometers, which will measure the incident energy. So we continuously get the values. It goes from 30, 40, 50, around 1000 watts per meter square, 1100 watts per meter square, like that. And cumulatively, we get the total energy received from the sun on any given day. And equivalent energy output is also calculated. So we do compare how much energy we received from the sun and how much we generated. And in fact, all of them are identical capacity. So one-to-one inverter sharing is also there. Means you can compare one-to-one inverters also.
Thank you, sir. Next, one more thing regarding the monsoon season and summer season. you are saying that the icing is the one issue. If any other issue between the monsoon season and summer season you are facing in this station? Because of
whenever it rains, no one can venture into this. We have to be that mute spectators. And whenever there's a wind, our boats cannot reach that location. So monsoon maintenance is a challenge. If it is raining, you cannot go there. And if there is high winds, also it will not be able to go there. And that's all. There's nothing other than that. Is only approaching the equipment. And whenever it rains, definitely there will be one or two these ground faults.
the identification will also take some time. Downfalls.
Take some time. Yes. What they do is in the 70 megawatt inverters, we are having 3 different buses. So we first check at the inverter that level and isolate that particular bus and put the inverter back into service. Basically, we check the voltage, whether it is floating or not. If it is not floating, that bus will be isolated and that remaining, these 2 buses will be kept in service. And then subsequently, one by one, we have to identify.
Sir, one more question regarding in our case, there are large reservoirs in our KCB. Whether in the reservoirs, whether in the water level varies around 40 to 50 meters in the large reservoirs.
Yes, sir.
Whether it is practical to implement these floating solar plants in our reservoirs?
Yes, sir, it is
With the
possible. Yes, sir, it is possible. People have been doing that. Basically, this anchoring rope is to be adjusted for that variation. So there are ropes which are having some that spring type ropes. So whenever the water level that rises, it goes up, and whenever it comes down, it compresses. I think that particular type of rope has been used in your Banasur Sagar Dam. So that particular type of anchorings have been there. And yes, it is possible, but it is again a challenge. That engineering challenge is there, because even with the 1.5 meters, and if people are not cautious enough, then the anchoring will go that here and there. That is a problem what we have faced subsequent to commissioning.
Thank you, sir. I have already covered all the questions in the chat box, and the sir has already replied to these questions also. Whether any members have any additional queries or any clarification on the reply from the Anand sir, we can ask.